So we're asked to calculate the speed of a transverse pulse in a string under a tension of 20 newtons, and we're told that the string has a length of 2 meters and a mass of 0.3 grams. Well, the formula that we need to remember is that the velocity for such a pulse is equal to the square root of the force divided by the mass per unit length, or in this case, writing the mass per unit length explicitly, the mass divided by the length. So the only place where we might make a mistake here in our substitution is because the mass has been given to us as being equal to 0.3 grams, and we will need to express that in kilograms to have this in SI units. Well, a kilogram divided by 1000 is equal to a gram, and therefore we can directly substitute and see that the mass is 0.3 kilograms divided by 1000, which is 0.3 times 10 to the minus 3, which is 3 times 10 to the minus 4 kilograms. So our velocity is equal to the square root of the force of 20 newtons divided by a mass of 3.0 times 10 to the minus 4 kilograms divided by, in turn, the length of 2.0 meters. Okay, so I want to keep the units nicely here, so I'm going to remember that a newton is actually also equivalent to a kilogram meter per second squared. The divide by 2 meters can be taken to the top as a multiplication in the fraction, and looking at the units alone then, the kilograms will cancel and we'll have meters squared per second squared, which when we take a square root will become meters per second. So we haven't made an error of the units, and when we substitute in the numbers and do our calculation, we'll find that the velocity is 365 meters per second. And make it clear that this is your final answer, and we're done.